Hello guys, it's Prof and welcome to C++ Digest video tutorials. In this video tutorial we are going to talk about data types. Now, a data type is a set of values with a set of operations. A set of values with a set of operations. Now, C++ data types can be grouped under three categories. Or we can have what we call the simple data types. Then we can have structured data types. Then we can have what we call pointers. Is that okay? So these are the main categories of C++ data types. Now, of course, each of these categories has its own sub categories. For example, when we talk of the simple data types, now they are the fundamental data types because they form the building blocks of the structured data types. Is that okay? They are fundamental. So from the simple data types we can have our structured data types and even our pointers. Is that okay? Now when we take the simple data types, they can also be grouped into three main categories. We can have the integral data types. We can also have the floating point data type, then finally the enumeration data type, or enum for short. Is that okay? Now when we talk about integral data type, it's simply, or it refers to integers, whole numbers, that is numbers without any word decimal point. Is that okay? So you say that they are numbers or without any decimal points. Is that okay? So talk of the whole numbers, talk of integers, they are all integral data types. Then when we talk of the floating point data types, we say that they are numbers with decimal points. So any number that has a decimal point is referred to as the floating point data type in C++. Then we have the enumeration type or the enum. The enumeration type deals with user-defined data types. Is that okay? They deal with the user-defined data type. Now when we start looking at them, you will get to understand what it means by user-defined data type. Now when we take the integral data types, it also has sub branches or sub classes. Is that okay? We have the boolean, which is shortened as the bool. We have the characters, which is char. We have the int. We have the short. We have the long. We have long. Is that okay? You have long. Let me put a comma here. You have long. So when we talk about the integral data types, we have the bool, char, int, short int. Let me put comma between them. So here that, here that. Is that okay? These are the integral data types. Now actually this guy is called short int, but also when you use just short, it will be accepted. Now these data types may be signed, or unsigned. Now when we say that a data type is signed, that means that it can take on negative values. Is that okay? It can take on negative values like -5, -10, -16, -1 million. When a data type is signed, then it can take negative values. Now when we say that it is unsigned, then that means that it cannot take negative values. It can only take positive values. Now these two keywords here are very useful when we want to deal with numbers that should only be positive. In that case, we mark it as what? Unsigned. And once we do that, that means that we can't assign a negative value to that particular number. With a signed and unsigned, take note the boolean can't be signed or unsigned. With the exception of the boolean, the rest of the integral data types can be signed or unsigned. Now the boolean data types, the data type is stands in for true or false. So it has just two values, either true or it is false. Now each of these data types has a specific range of values that it can handle. The boolean data type, like I said, handles just two values. It's either true or false. Is that okay? It's either true or false, and each of them take a different amount of memory. That is the most important thing. Each of them take a different amount of what? Memory. Now for your assignment, I want you to go and check on the ranges that the integral data types operate on. I have written a sample program that we will use to show the amount of memory that each data type takes. Now the floating point data types, they include the floats, we have double, we have long double. These are floating point data types. Is that okay? And the difference is due to their precision. Is that okay? There's a single precision, a double what? Precision. Is that okay? Then in the integral data type, we can use the E notation. For example, instead of saying 0.0009, we can say 9.0 E. Then how many times? 1, 2, 3, 4, 5. E minus what? 5. Is that okay? The E stands for times 10 raised to the power. Is that okay? E stands for times 10 raised to the power. So these are all about the data type. So let's go to our program and let's see how much data or how much memory space each of these data type can take. So I've written a simple program here. I've declared variables with all the data types. Now something that I want to talk about, we have two preprocessor directives added to our already defined IOStream processor directive. We have the strange, we have include strange, then we have include cstdlib. cstdlib stands for C standard library. Now the reason why we have included these two preprocessor directives is because one, we are going to make use of system, and a call to system or system is defined in this particular library, the C standard library. So if we want to be able to use system, then we should have C standard library imported or added to our program. Then the strange is another type of data type, but it is programmer defined. The strings are regarded as programmer defined data types. In programmer defined data. So again, if we want to use a string, and a string is simply a collection or a sequence of characters. Because we'll be using string, we have to include it. So I declared a string variable and I called it what? My name. Now there is something called the size of function. Is that okay? Now this size of function, what it does is it takes the name of a variable and it tells you the amount of memory that variable takes depending on its data type. Is that okay? So for example, when you run this program, it's going to print the data, the amount of memory that character data types take, amount of memory that short data types take, amount of memory that boolean data types take, amount of memory through strange data types. So let's run this program and look at this here. We have system and we have color 0A. Now that is going to show some difference in our console, and I will explain it later. So now you can see that we have green fonts, or our letters are written in green, and our background is black. That is what this guy is doing here. He has setting the color. 0 stands for black, A stands for green. Now the first character stands for the background, the second stands for the foreground. So for example, if I change this A to E and rerun this program, my fonts change to yellow. Is that okay? Because that is the yellow is E stands for what? Yellow color. So I prefer my A, so set it back. Now in case you want to find out more about this console color thing, this is the code you have to run. Color / so after writing your program, you can uncomment this, add this to your program, and let me show you what it will do. Good. So it will print, it will help you get all the colors and what they do. So remember, if I select 8 something like 80, the first letter stands for the background and the second letter or character stands for the text color. So if you add that piece of code into your program and run it, it will bring up this thing, then you read through it and have some fun with your IDE. But at the meantime, I don't need it, so I'm going to comment it out. Okay, now let's get back to what we are doing. So if we look here, I will explain this code later, but now what I want to explain is the amount of memory space that each of the data types takes. So we have character takes a memory space of what? 1 byte. Look here, I didn't write it. I only pass the character variable to the size of operator, and it is computing the amount of space that it takes. So it says that a character takes a memory space of 1 byte. So is a boolean. Boolean also take a memory space of what? 1 byte. Short takes a memory space of 2 bytes. So if we declare something as a short data type, it will occupy 2 bytes of our memory space. If we make something an int, it will occupy 4 bytes of memory space. Is that okay? If we make something long takes 8 bytes of memory space. Is that okay? So if you are going to say something like date of birth, you are going to say something like your age, you know that nobody okay, anyway, I won't speak about that. Go and check on the range of values that all these data types operate. Is that okay? Then I will explain what I wanted to say in probably my next video tutorial. So if you also define something as a float, look at it. A float also take what? 4 bytes of memory space. A double data type takes 8 bytes. Then the long double takes what? 16 bytes. Strange also takes a memory space of 8 bytes. Now listen to this carefully. Most often, this the amount of memory space that a data type can take is OS dependent. I mean operating system dependent, and it sometimes depends on the type of compiler you are using. Is that okay? Now I know that some of you, if you try to run this particular program, you are going to get long double to be something like 12 bytes, 12 bytes, then double to be, let's say, 10 bytes. All you have to know is that some of these things are what? Operating system dependent, whether you are using 32-bit or 64-bit, and sometimes to the compiler you are using can contribute. So if you write this program and you are not getting this same output as mine, don't be bothered. That is because your operating system is providing you with those values. Okay, so let me just scroll through this program. So if you want to repeat it, all you have to do is to pause. So it starts from here through here to here, then that is the end side. So you can pause your screen and do the same thing and run it on your machine and check how much memory is allocated to the individual data types. All right, now let's talk about what we call arithmetic operators. In maths, when we talk of arithmetic operators, then four things come into mind: addition, subtraction, multiplication, and division. Is that okay? These four things come into mind. Now in C++, when we talk of arithmetic operators, is the same as that of mathematics arithmetic, just that there is a new thing that is being introduced. So in C++, we have addition, subtraction, division, multiplication, and modulus. Is that okay? Now this modulus is also known as the remainder operator. It is used to find the remainder of two operands. Is that okay? For example, when 3 is divided by 2, what will be the remainder? So if we do something like 3 mod 2, the answer you get is 1. That means that if 2 divides 3, you get 1 as a remainder. So take note, the modulo or the remainder operator is only interested about the remainder. Now these operators can be unary, binary, or ternary. When we say that an operator is unary, before I even do that, let me explain this. If I write 4 plus, this is 7. Is that okay? 4 and 7 are called operands. 4 and 7 are called operands. They are the values that are being acted upon by this operator. So the addition is the operator. So take note, the numbers are called what? Operands, and the addition, or the multiplication, the division, they are called the operators. So now back to our classification. When we say that an operator is unary, then it means that it has only one operand. Is that okay? Any operator that has only one operand is what? A unary operator. For example, if I write -5 here, the negative symbol is acting on only one operand, which is 5. So it becomes what? A unary operator. If I write +8, the positive sign becomes a unary operator because it's operating on only one operand. And we have a whole lot of unary. All that you have to know is that they operate on only one operands. Then when we say that an operator is a binary operator, if we say it's a binary operator, then it has 2 operands. Is that okay? A binary operator operates on 2 operands, and almost all our arithmetic operators are binary operators. So for example, if I write 5 plus 2, is that okay? Or 12 minus 9, or 8 divided by 2, or 4 times 5. See that each of them is having what? 2 operands. Each of them is having 2 operands. So we say that they are binary operators. Then we have ternary operators, and a typical example is the ternary operator, is a question mark sign, whatever. Now this is how to use it. These operators have three operands. So any operator that operates on three operands at a time is called what? A ternary operator. And for example, if I write 3 equals to 4 and I bring a question mark here, 5, 9. This is my first operand, this is my second operand, this is my third operand. Is that okay? So that makes this particular question mark sign a ternary operator because it acts on three operators at three operands at a time. Now we have something we call order of precedence. Is that okay? Now in mathematics it's equivalent to be what we call board mass. That is bracket of division, multiplication, addition, subtraction. Board mass. Now when we talk of order of precedence, it's just a way of going about how to solve an arithmetic expression when we have mixed operators. For example, division, multiplication, and modulus are the highest. Is that okay? They are the highest arithmetic operators. I mean, they have the highest precedence. Is that okay? They have highest precedence. Then the subtraction and addition follows. Is that okay? Subtraction and addition follows. Now assuming we add our assignment operator, okay, I won't add that right now. Now what this means is that whenever you are stuck in an expression containing these operators, one or more of these operators, you try to evaluate those at the higher precedence. So for example, if I have 3 plus 7 minus 6 divided by 2 times 4 mode 3, mode 3. If I have this, how do I solve it, or how will C++ evaluate this expression? Look, seeing that we have almost every arithmetic operator in, now C++ applies this rule of order of precedence. Is that okay? So because division, multiplication, and modulus are at the top of the precedence, C++ will first run through this expression and evaluate them first. So our next step, we are going to have 3 plus 7 minus 6. Is that okay? Minus, now when we come here, there is a division sign over here and it's operating on 6 and 2, so that will be 6 divided by 2, which is what? 3. So we have minus 3. Is that okay? Then right after that, when this gives us 3, we now have what? We now have times 4 modulo 3. Then our next step is going to be 3 plus 7 minus 3. Now between this and that, is that okay? There is a multiplication sign. Then one more thing, because division, multiplication, and modulus are at the same level of precedence, when they are present in an arithmetic expression, the compiler adopts the method of left to right. Is that okay? It sorts from left to right. So because this comes first before this, it will evaluate this before evaluating that. Is that okay? That is the concept of, or the convention of solving from left to right. So we have 3 times 4 over here. That means that will give us a 12. Then we have mod what? 3. And last but not the least, we have 3 plus 7 minus. Now we can evaluate our mode. Is that okay? Now 3 can divide 12 4 times without any remainder. So that will give us a 0 over here. That will give us a 0 over here. Then finally we evaluate our positive and negative. So we have 3 plus 7 minus 0, which will give us what? 10. So if C++ should solve this, this is the answer that it will what? It will produce. Is that okay? Now, mostly to make our work easier and make life easier, it is advisable to introduce what we call parentheses. Parentheses. Is that okay? So for example, if I put parentheses on these guys and put 1 here, that is definitely going to change the answer of our expression. Is that okay? Now remember, in board maths, in mathematics, we say that evaluate what? Bracket first before you do any other thing. So once bracket or parentheses are introduced, then C++ will first evaluate those things in the parentheses before it applies the order of precedence. So that means that the parenthesis is on top of every order of precedence. So here, despite the fact that addition is between 3 and 7, because of this parenthesis, it will be evaluated first before any other. So if C++ is solving this first, it's going to deal with this, and that will produce what? 10. Sorry, 1 2 3. So that will give us what? 10. It will not touch this 6. It will not touch this divided by 2. It will not touch the multiplication. To come straight here and evaluate this. And 4, when 3 divided by 4, we get a remainder of what? 1. So right now that the parentheses are gone, then we apply the order of what? Precedence. Is that okay? And then rule of left to right. So here to 10 will not be touched, but there is a division here. So we have 6 divided by 2, which is 3. Then we have times what? 1. Is that okay? So repeat our times 1. Still there is multiplication here, and it is higher than minus. It's higher than minus. So we have 10 minus, now 3 times 1 will give us what? 3. Then finally we have 10 minus 3, which is what? 7. So you see, when parentheses were introduced, we had 7. We have parentheses, we have 10. Now if we reach a if we remap the positions of the parentheses, if we change it right now, we are going to get a different answer. So you have to be very careful, and always by convention, it is very good, it's a good habit to use parentheses to differentiate between what should be done first and that stuff. Okay. Now we also have the strange data type. The strange data type. Like I said, when we were here, I told you that we'll be using what? The string, and I said that the string data type is a programmer defined data type. Is that okay? It's not part of the C++ fundamental or core data types. Is that okay? So let's look at the string data type. A string is a sequence of 0 or more characters. So if I do this, or if I do this, hi Abigail, is that okay? This is a strange. Is that okay? This is a strange. This is a null string or empty. It contains no character. This is what? A string that contains characters. So we have character H. This, and take note, a space is a character. Is that okay? Space is a character. Now, to denote a string in C++, we put it in double quotes. As you can see here, we put that particular thing in what? Double quotes. So this is double quotes, and because there is nothing in it, we say that this is a null or empty string. Is that okay? A null or empty string because it contains nothing. And this is a good. Then let's say hi Zeta, how are you? This is also what? Strange. Is that okay? All you have to know is that in C++, a strange is put in between what? Double quote. Then characters as we have here, characters are put in between single quotes like this. So if I want to say character D, you put characters in between single quotes, then you put strings in between what? Double quotes. It's something that you have to take notice of. Strings are placed in between double quotes, characters are placed in between what? Single quotes. It's part of the C++ syntax rules, and if you go against it, you will be in trouble. Now, the position of each character in a string can be identified by their index. Is that okay? Each particular character in a string has a position. Is that okay? And we call that position the index. So for example, position Z in the string hi Zeta, how are you, will be 0, 1, 2, 3. Is that okay? Remember, space is also a character. Now, in this particular string, we have hi Abigail. Let's count the number of characters. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that okay? We have 10 characters. That means that the first character runs from is at position 0. The last character is at position 9. First character is at position 0. Last character is at position 9. That means that the string has 10 characters. Always remember to refer to the first character at position what? 0, not position 1. So for example, in hi Zeta, how are you, we have the letter Z at position 0, 1, 2, 3. Is that okay? It is at position 3, and that it makes it the fourth what? Character. Is that okay? Then in hi Abigail, the L is at position, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that okay? It is at position 9. That makes it the 10th what? Character. So these are some of the things that you are to take note. I will discuss thoroughly how to use the strange data type, but this is something that you have to know. You have to know something quick about it, that when we talk of a string is a sequence of 0 or more characters. 0 or more what? Characters. So there can be no character, but make sure your double quote is there, or there can be characters inside what? Double quote. And the only way to differentiate between a string and a char is that strings are put in double quotes, and strings involve one or more words. Strings involve 0 or more characters, but a character is put in between a single quote, and it can take just one character at a time. Can take just one character at a time. So thank you guys for watching this video tutorial. If there is something that you don't get it, just pause the video and watch it over and over and over. Remember, practice brings perfection. And if you find any problem getting along, you can pass your comment or suggestion on our WhatsApp group or our Facebook page, and the necessary attention will be given to you. Thank you guys. And one thing you have to note, I want you guys to give me feedback, because this tutorial is meant for you. It's meant for your SAS and C++ programming. That means that this tutorial will achieve success if you guys are able to do the C++ programming well. Is that okay? And I am not making it for myself, I'm making it for you. So if there is anything you think should be done, please let me have that feedback, and I promise I will make the necessary changes or whatever is necessary to make sure that what you are requesting is being met. So thank you guys for watching this tutorial, and don't forget to watch my next tutorial. See you in the next tutorial.